A revolution in the automobile industry is underway. Consumers are demanding electric vehicles, and governments around the world are calling for a complete transition to EVs in the next decade. The automotive manufacturing industry is responding to those demands in a big way. New companies such as Tesla, Rivian, and Lucid are trying to break into the market, and traditional manufacturers such as Ford and GM are retooling their assembly lines to produce more EVs. But it's the makers of auto parts who could be most effective. As the world shifts to EVs, which manufacturers will be unable to adapt to this transition, and who will emerge from the revolution unscathed? Find out now in this episode of Mechanical Engineering Magazine's Special Report. The automobile industry has been evolving for more than 100 years, but over that time, most cars and trucks have been manufactured with a similar plan. A gasoline or diesel-fueled engine provides power to a mechanical transmission system that drives the wheels. While it may be simple in concept, it is mechanically complex. A typical car has more than thousands of moving parts. Electric vehicles may look very similar to a standard car or truck, but they are quite different under the skin. Large banks of batteries provide electric power directly to motors, either on the axle or close to the wheels themselves. The motor in an EV has 3 moving parts, compared to more than 100 in an internal combustion engine. That mechanical simplicity means that engineers and automotive designers who work on electric vehicles can start from almost a clean slate.
We're aggressively hiring in that space, very aggressively hiring into electrification, electronics, software. Really are probably the key growth areas from an engineering perspective.
When Ford started redesigning its flagship F-150 pickup to become an electric truck, it discovered that the motors, batteries, and other parts of the electric powertrain fit snugly along the chassis. That left room for a spacious interior and a large, covered storage area where the engine would have been, all without changing the basic envelope of the truck. Electric vehicles have also attracted startup companies that are not tied to the traditional methods for manufacturing cars. These companies, such as Tesla, Rivian, and Lucid, are in some cases drawing on the manufacturing practices found in the electronics or aerospace industries. Like many automakers, Rivian has had difficulty obtaining computer chips for its electronic systems. By some accounts, the plant moves into full swing when it has enough parts to complete the vehicles, but often the assembly line sits idle. The simplified design of electric vehicles will create a shift in the number and types of auto parts being manufactured.
Yeah, so a lot of most of our customers today will be our customers in the future, and they're going through the same journey we are.
In many cases, they will be able to apply the competence they have developed for conventional vehicles to electric vehicles.
All that historical knowledge that we've developed over 118 years, that really remains and carries over to EV. If you think about it, the physics of moving earth, moving building supplies, moving freight or people, they really remain the same.
One example is thermal management. As vehicles operate, working parts generate heat, which needs to be shed so that vehicles can maintain peak performance. BorgWarner specializes in fans for large commercial vehicles, which are driven by the internal combustion engines. In EVs, that mechanical system is replaced by electric motors.
So we're leveraging what we have, and then we're also now building out some of the core power electronics and electric machine capabilities that also exist within the company. So it's a bit of I guess, an extension of things that we've done historically into a new space where you have thermal management challenges in electric vehicles as much as you do on the internal combustion engine.
Change in the automotive industry is happening fast. While some countries are on the road to switching over to EVs, that change won't be complete for another 10 years or more. During that time, gasoline-powered cars and trucks will still be driven, and the conventional vehicles that are sold today will still be on the road for decades to come. Those vehicles will need replacement parts.
We also expect that our core mechanical driveline business is going to remain strong through 2030. And when those vehicles transition, they're mostly going to be a transition from mechanical with ICE to mechanical and integrated powertrains.
The auto companies that adapt to this reality and produce high-quality, low-cost components and vehicles will be able to dominate this new automotive landscape. For parts suppliers, the growth of electric vehicles means that they will have to make some important decisions. Companies that are deeply rooted in conventional vehicles will have to add electric capability, while those that are already in the market, such as Dana and Borg Warner, can shift investments to develop cutting-edge technologies to preserve their position. The switch over to electric vehicles will have a wide-ranging impact on the entire automotive industry. It's a story that will take decades to unfold, but it is starting right now.